Okay, so let's begin. So what we did last time is we talked about elimination method by using elementary Hermitian matrices. Okay. So where we basically find elementary Hermitian matrices and multiply them in that order, and then we derive. We get an upper triangular matrix, and then we solve the system by using that upper triangular matrix, or solving the upper triangular matrix system. So today what we are going to do is we are going to start talking about some other method for solving a system of equation that is known as iteration method. Right, so iteration methods to solve a system of linear equations. So what we did already is the elimination methods. So what we are going to study here is the iteration methods, right? So here iteration method means this. Right? So here what we do is okay, so this is what we do in iteration method. What we do is we want to solve the system Ax equal to B, right? But what we do here is we start with an initial guess x naught. Right? Later on, we are going to see how we can make those initial guess. Right? And then what we do is we try to create a sequence xk, right, which are going to be the approximations for the solution x. Right? So more importantly, those approximations will eventually convert to the real solution x, or convert to a much better approximation of the real solution x. Right? So this is how we are going to create solutions. So that is what we call iteration method. So you start with an initial guess and you keep on computing more and more. So how we can achieve this? That is the question. So now we have to have a procedure. So we have to construct the iterative method. How we can construct the iterative method. So first step is first
Excuse me, sir. Body is little blurred, I guess.
what's the problem?
Body is not clear. I mean, blood.
It is blood.
Yeah.
Okay, let's see. Is it okay now?
Same, sir. Yeah, earlier it was okay, but I think connection went wrong.
Okay, let me check.
Try பண்ணு zoom ஆகுது பாருங்க போர்ட்
முடியல ஆன்லைன்ல இருந்தா ஆன் பண்ணி கொடுங்க.
zoom is it okay light off பண்ணிட்டேன் சார்
Bit okay, miss.
இப்ப கேளுங்க
Is it okay now?
Bit okay, sir, but we can't see the full board.
full board okay I'll minimize இப்ப வருங்க கொஞ்சம் கூட்டு maximize பண்ணுங்க இல்ல கேமரா அதான் வருவாங்க சமந்தா சரி zoom பண்ணுங்க சார் மேக்ஸிமம் இன்டர் கிளியர் இல்ல தான் is it okay now
Small letters means it's still not clear, but large letters fine.
Small letter தெரியலையா? Small னா என்ன? கொஞ்சம் பெருசா பெருசா
போர்ட் தெரியல clearly.
கொஞ்சம் கிட்ட கொண்டு இல்ல இவ்வளவுதான் ஜூம்ல இல்ல அஸ்தி வேற முள்ள போய் அசைட் பண்ண
family மறைக்கிறப்ப zoom up இந்த கேமரா நேம் எல்லாரும்
மிஸ் இதுல இருக்கிற இந்த ஒரு லைட்டை போடுங்க
லைட்ஸ் போட்டா
இல்ல சில வேளை ஷைன் பண்ணு மிஸ் லைட் ஆல இந்த வேலை வருது மிஸ் பிள்ளை எனக்கு தெரியும் விளங்குல சிக்கல் சட்ட சிக்கல் நாங்க பின்ன என்ன இப்படி ரெண்டு செய்யறோம் இப்ப போடுங்க இத is it clear now?
Better than before, miss.
Better than before.
Yes, now it is readable, but it's still not clear, but can be.
It's readable. Okay, I now the letter sign
Okay, miss.
readable, right?
Yeah.
Okay, thank you to Samantha for the technical support. Even okay, so what we do is we try to write the matrix, the coefficient matrix A as I minus M. So I is the identity matrix which you know you have ones on the diagonal, and then M is the matrix which has zeros, which should have 0 on the diagonals, right? So here is how we can do that. Let me give you an example. So say suppose you have a system like this. Okay, so suppose you have a system like this. So this is an Ax equal to B system, right? So what you first do is you divide the diagonal terms, or you make sure that the diagonal term is 1. So if you want to make this 1, then what you do is you divide this row by 3, so that this whole thing become, the diagonal term become 1. So here what you do is you divide this by minus 2. Here the diagonal term is 5, so you divide this by 5. Right? So if you do that, this is what you are going to have. 1, 2, 3, and then here x1, x2, x3, okay. And then on the right hand side also you have to divide. So when you divide 12 by 3, you get 4. This you divide by minus 2, right? So because diagonal term is minus 2, you want to make it 1. So you divide everything by minus 2. So when you divide this by minus 2, you get minus 1, you get 1, and you get minus 2. And here you divide minus 8 by minus 2, so you get 4. Here you divide by 5, so you get 1, minus 2, 1, and then 3. So now if you look at the diagonal terms, right, all the diagonal terms are 1. So that is the first step you do. So you divide each row of the system by the diagonal term, so that the matrix A will have 1s on the diagonal. Right, so this is your matrix A. Right, so this is your matrix A. So now what you can do is you can write A as I minus M. where I is an identity matrix and M is a matrix with zeros on the diagonal. Okay, so here you can see that now. So you have A is basically identity. So 1 0 0 0 1 0 0 0 1 minus M, a matrix with zeros on the diagonal. So there the ones already gone there. So you have 0 minus 2 minus 3 1 0 2 minus 1 2 0. Right, so you wrote A as I minus M. Right, so I minus M. So you write A as I minus M. This minus this is equal to this. You can verify that. So this is the first step we do in the iterative construction. So first step is you write A as I minus M. So in that process you can see that this is your B, but when you do that it becomes a new vector C. Right? So you notice that when you are converting the matrix A as I minus M, you change the right hand side vector as well. Right? So that is right. So that is this is what you get. If you have Ax equal to B originally, then you can rewrite this as I minus M times X plus C. Okay. So here you write A as I minus M. So this is the first step in the construction of iterative method. So you write A as I minus M and substitute in the system. So you get I minus M times X is equal to C. So now we will start from here. Right? So you can distribute this X inside. So the idea of creating an iterative system is if you want to solve, if your question is to find the solution X in an iterative method, what you want to have is you should have X on the right hand side and X on the left hand side, then only the iteration works. So in this system, right, A is equal to B, you can see that you have only one X that is on the left hand side of the system. Right hand side you don't have X. But the idea behind creating an iterative system is to make sure that we will have X on the right hand side as well as X on the left hand side. So this can be done from this line, and because if you distribute X, you get X minus Mx is equal to C. Right? So when you distribute X, you get X minus Mx equal to C. So this is basically equivalent to X is equal to Mx plus C. So you brought Ax equal to B, and this is the original equation, but you are able to rewrite it as X minus X is equal to Mx plus C. Right? So from having X on only one side, now what we do is we are able to rewrite this of having X on two sides of the equation. Right? So that is how we construct the iterative method. Right? So what we do is after doing this, so after doing this, you know that when we define iterative method, we say that we will start with an initial value x naught, and we try to create sequence of numbers x1, x2, x3 and so on. Right? So okay, so what we do is we write the iteration as xk plus 1 is equal to m times xk plus c, where k running from 0, 1, 2 up to infinity. So here, if x naught is given, right, when k is equal to 0, if x naught is given, you can compute x1. And then if after computing x1, you put it here, x1, then you get x2. And then you put x2 here, you get x3. You get x4 here, x5. Like that, you computing one value and use that, and then again you compute the next value, use that, compute the next value, and you keep on using and keep on computing those values, right? So that is how we create iterations basically. This is called one kind of a general iterative formula. Right? So this, in a way, will help you to find a solution. Right? So let us see an example. Okay, so for simplicity, let me write this in this way. For example, okay, so let us apply, let us say we have a system like this. Right? 1, 2, minus 1, 2, 1, minus 1, 1, minus 2, 1 is a system. Right? So the question is, by using the initial value x naught, which is 0, 0, 0, right, all zeros as the initial value, and they want you to compute the next two iterations, x1 and x2. So you have to compute this. So here is the iterative formula. So you have to apply the iterative formula and you have to compute the values. So you know that the first step is you want to find what is m and c. So here, clearly this is your a, right? So you can write a as I minus m. And so let me write the solution. So here you know that already you have ones on the diagonal, so you don't need to divide anything. Here one, here one, here one. So you don't need to do any division because it's all one. So you can immediately write this as a as I minus m. So if you write a as I minus m, you can easily see what is your m. So that's going to be 1 minus 2 0 1 minus 1 2. This is your m. Right? When you write a as I minus m, obviously you can see this is your m. Once you get this m, you know your c is this because you divide everything by 1, so there is no change. And so this is your c. So once you know m and c, you can apply the iteration because those are the two things you need to know. C, m and x naught. X naught is given, you find m1, m and c, so you can apply this. Right? So let me apply the equation. So they ask you to do 2 iterations, so you have to do 2 steps. And recall that this is your iteration. Right? So this is your iteration. You have to apply 2 steps of this. So step 1, you put k is equal to 0. If you put k is equal to 0, you can easily see that you will get x1 is mx naught, right? So m is this 0 minus 1 1 minus 2 0 1 minus 1 2 0 times x naught. X naught is 0 0 0 plus c. So that is 1 2 0. Right? So when you put k is equal to 0, you remember you get x1 is equal to mx naught plus c. That is the iteration you will have. So you can compute this. So this multiplied by 0, so all these are 0 0 0. Right? So you will end up with this 1 2 and 0. So that is the first step. Second step, you put k is equal to 1. When you put k is equal to 1, you get x2 is equal to mx1 plus c. Right? x2 is equal to mx1 plus c. So again, you do the calculation. So your x2 is going to be m, so 0 minus 1 1 minus 2 0 1 minus 1 2 0 times x1, that is this, right? So 1 2 0 plus c, that is again 1 2 0. So this time you have to multiply because this time you have to get this multiplication done. Earlier it is all 0. So when you multiply everything by 0, you get 0. So you don't need to worry. But here you have to multiply. Right? So if you have to multiply, then minus 1 times 2, 0 times 1 plus minus 1 times 2 plus 1 times 0. So you multiply, add them together. So obviously you get minus 2. Right? This row by column minus 2. Now this row by column, again minus 2 times 1, that is minus 2. And again this row by this, so minus 1, 2, 0, so minus 1 plus 4 is 3. Plus c, that is 1, 2, 0. Now if you add these two, you get minus 1, 0, 3. right? So you can recheck the work. Sometimes there may be some mathematical errors, but just computation, so you can easily verify it. So here you see that x2 is equal to m times x1 plus c. So you compute m times x1 and add c, you get this. So if you continue doing this, right? So as a homework, what I am going to do is to right. So as a homework, you try to compute this, right? So x3, x4, x5, x6, and so on, right? So just a few more calculations and see whether it is going to some number or it is going way off, right? So that is a good example. This is a good example because this will give you a hint that we need to have certain conditions for the sequence to be converging. Right? So not necessarily all the sequence we generate here converges to the solution. Right? So sometimes we need to have certain conditions such that the sequence converges. Okay? So as a remark, I'm going to write it here. Right, so not necessarily all the sequences we have converges to the solution, right? So why that is happening is something we are going to see next, right? So not necessarily all the sequence converges. So we have to have certain requirements to be satisfied for the sequence to converge. So what are the conditions is what we are going to see next, right? But in general, this is how we define iterations, right? So this is a general idea of how we can define iterations, right? So for this general formula, we are going to see how we can justify convergence, and then by choose. So now here the idea is this: you choose M, right? The M is here, you just split the matrix I minus M. Okay? So there are other ways to split the matrix as well. Right? So that will give you different types of iterative methods. So I will write that as a remark again before going into the conversion. So another remark again. right? So instead of writing A as I minus M, we could have write A as I minus L minus U, where L is a strictly upper triangular matrix and U is a strictly lower triangular matrix as well, right? So for example, this. Right, so if you have A as this, right? So then you can write this as I minus L minus U as well. L is U is this. Okay, so you can write this matrix A as I identity matrix minus L, which is a strictly lower triangular matrix, no elements on or above the diagonal, right? Minus U, an upper strictly upper triangular matrix, so that means no elements on or below the diagonal. So this is another way of writing A, right? Instead of writing I minus M, you can always write A as I minus L minus U. Like always, the first step is you divide by diagonal terms. That is not a big deal. If required, you divide by 1. Otherwise, you divide by the corresponding diagonal term. So that's again obvious. So now you can write A as I minus L minus U. So in place of A, you can write I minus L minus U. So that will give you different type of iterative methods. So later on in this chapter, that is how we are going to do. We will start writing A as I minus L minus U, and then we will start writing or deriving different types of iterative methods. Right? So that we will come back later on sometime. Now what I am going to do is I am going to tell you the condition for the convergence of the iteration which we defined earlier. Okay, so I'm going to write this as a theorem. Okay, so here what we say is, if the spectral radius of the matrix M, right, which is the largest absolute value of the eigenvalue of the matrix. Right? Spectral radius is the largest of the absolute values of the eigenvalue. So that if that is strictly less than 1, then for any arbitrary initial guess x naught, the sequence will converge to the solution of the system. Right? So this is what we need for the convergence. Right? The spectral radius of the matrix M should be less than 1. Right? So we shall prove this. So if and only if prove, so if the spectral radius is less than 1, then we have to show that the sequence converges. And if the sequence converges, then we have to show that the spectral radius is less than 1. And so first assume that the spectral radius is less than 1. And so suppose right, rho m is less than 1. Right? If spectral radius is less than 1, then you can say that right, so you can say that the matrix norm of the matrix M is less than 1. And you should have learned these norms and everything on earlier mathematics courses. If not, after completing this section, we can go back and re-refer norms and everything, because that's something not relevant to this course, right? The definition of norm and everything should have come from a lower level. And now we see that if the spectral radius of M is less than 1, then there is a matrix norm such that the spectral radius, the norm of the matrix M is less than 1. Right? So now what we are going to do is we have to prove the convergence. That is not a big thing. Because you know that this is your iteration. First, you know that Ax equal to B can be written as I minus M times X is equal to C. Right? So that is clear for you. You write Ax equal to B implies I minus M is X is equal to C. So from this you know you get X is equal to Mx plus C. Right? So that is clear. If X is a solution of the system, you know that X is equal to Mx plus C. Right? So we have to show the convergence. At the same time, you have X k plus 1 is equal to Mxk plus C. That is your iteration. Right? So this is how you define iteration. So now what you can do is to subtract one from the other. You subtract, you get xk plus 1 minus x is equal to m times xk minus x. Right? You get xk plus 1 minus x is equal to m times xk minus x. So now you take the norm on both sides. Right? Norm is basically a size. Right? So size of the vectors or matrix, whatever it is here. So when you take the norm, then you get xk plus 1 minus x is less or equal to norm of x times norm of xk minus x for all k greater or equal to 0. And so when you take the norm, you get an inequality. Xk plus 1 minus x is less or equal to m times xk minus x. So this is a relation which is true for all k. So if it is true for all k, then you can do it for any values. So here what I am going to do is I am going to continue doing this. And so you notice that xk plus 1, or I can start with xk, that's not a big thing, minus x is less or equal to norm of m times norm of xk minus 1 minus x. Because this is true for all k, so if I put k here, I will get k minus 1 there. And so xk minus x is less or equal to m times xk minus 1 x. So now you apply for xk minus 1 minus x. So if you apply, you know that you get m squared times xk minus 2 minus x. Because xk minus 1 is less minus k is x is less than m times xk minus 2 minus x. Same argument. Right? So, and then there is already an m, so m squared k minus 2. And then you apply for k minus 2. So you get another m times k minus 3 minus x. So altogether you will get m cubed xk minus 3 minus x. So now you keep on continuing this, right? When you continue this, at some point you will get m to the power k times x naught minus x. Right? When you have m to the power 1, you have k minus 1. M to the power 2, k minus 2. M to the power 3, k minus 3. So m to the power k, k minus k, that is 0. So what you have is xk minus x is less or equal to m to the power k times x naught minus x. So now x naught is a given fixed value. X is the solution, so that is the fixed value. But right, so but m is less than 1, norm of m is less than 1. So 1 upon 2, 1 upon 3, 1 upon 5, whatever it is smaller than 1. And when you take it to the power kth power and letting k goes to infinity will goes to 0. And so you know 1 upon 2 to the power n will goes to 0 as n goes to infinity. Right? So you know that. Similarly, 1 upon 3 to the power n goes to 0 as n goes to infinity. So any number less than 1 to the power k goes to 0 as k goes to infinity. So now this whole thing, bigger thing is going to infinity, going to 0 as k goes to infinity. So obviously the smaller part will goes to 0. Right, so as k goes to infinity, norm of xk minus x goes to 0. So the distance between or difference between xk and x will goes to 0 as k goes to infinity. That means xk will get close to x as k goes to infinity. So this clearly indicates that xk converges to x as k goes to infinity. right? So this is how we prove the convergence, right? Whatever value you choose for x node, right, it does not interfere the convergence because the convergence is dominated by m to the power k, right? So eventually the sequence will converge irrespective of the initial value. So as long as rho m is less than 1, we prove that the sequence converges. In the next class, what we are going to do is we are going to see the other way around. We are going to see if the sequence converges, then we have to show that the spectral radius is less than 1. And after that, we will talk about other different types of iterative methods. Right? So we will talk about that on Wednesday class. Right, so I will stop here, and we will continue on Wednesday.